alkaline batteries market is a very strong one in economic terms. According to the site Battery University, the global market of this product is valuated in $50 billion US. Even though they are a very profitable product, 30% of their components result to be toxic and dangerous for human health if they stay in the environment. These two are the main reasons we chose this product to make a proposal of its reverse logistics strategy. Because it is very important to keep away from the environment the biggest possible amount of this product in order to reduce its dangerous effects. To start with the analysis, it's important to consider the carbon footprint. In order to make a proper carbon footprint analysis, it is important to consider the whole process involved in the making of the batteries. This means that steps from the whole supply chain have to be considered, or as it is also known as cradle-to-grave process. A study made by Schneider Electric shows the impact that these devices cause to the environment. For each kilogram of alkaline batteries, it is calculated that 1.14 kilograms of carbon dioxide are liberated to the environment. So, taking in consideration that in average are sold in Mexico 600 million batteries, each one with an average weight of 19 grams, we are talking about 11,400 tons of alkaline batteries, which lead to around 1,300 tons of carbon dioxide, which is a pretty big number.
Not only the batteries pollute the environment, but also the supply chain itself. This is also important to take into consideration because the reverse logistics solution to be proposed has to agree with the idea of eliminating some contamination on supply chain activities. As it can be seen, the main source of GHG emissions is the iron and steel mills, which produce one of the raw materials used by batteries. But this is not in our project scope. Trying to incorporate some of the logistic concepts to be identified later in this project, transportation is also an important source of pollution because of heavy amounts of diesel used. Not only the emissions caused from the fuel or diesel burning are important to take into account, but also mentioning that the different ways in which batteries are disposed also generates an important effect on the amount of CO2 they send to the atmosphere. As we can see in the graph, the best disposal methods would be those of retail drop-off and curbside pickup, because they have negative values for the generated CO2. As the diagram shows, the supply chain for the battery production starts with the raw materials, which are delivered to the production plant. The materials supplied are mostly the following: lead bars, plastic case and plastic accessories, acid and mixture materials. Efforts to recycle are already being made, but are not yet enough to compensate the great amount of damage being created to the environment. What reverse logistics say is that there is a way to keep track of the process after the customer has purchased the product with the intention of recycling the useful parts of the product. The most common pathways followed by a battery after they are no longer useful for the customers are landfill, curbside pickup, consumer drop-off in retail store, and consumer drop-off at municipal collection center. Even though this works, as proved by the following section in the impact, it doesn't actually work as good as everybody would think. The idea would be not to separate the afterlife cycle from the actual supply chain in order to have a process that looked somewhat like this. The most important part to note in here is that the product coming to the manufacturing facility from the recycling processes is now making up around 60% of the raw material.
Created using Powtoon.